Chris Kingsley here. It's been a couple of years since I've done a technical like video. A lot of things have happened since my last one years ago, like the cab project. One of the things that I've been working on is the layout that I have worked on for well over 10 years, putting a lot of time and detail in, and doing what is always difficult, and that is tearing all the buildings and structures and details off, cutting it up into a bunch of pieces, and sending it to the landfill. Subsequently, I started building a new layout using the lessons learned from my previous one. This includes a much more extensive electronic control system and equally a computer powerful enough to fulfill some of my ambitions for a new level of model railroading automation. One of the interface attributes that I really like is this beautiful 17-inch 4K touchscreen monitor that enables me to create not only an intuitive interface, but also present graphically rich graphics and animations. One of the projects you may remember that I worked on about 6 years ago was my ultimate throttle that enabled me to prototypically run my model locomotive from a simulated F7 cab. Subsequently, I donated that cab to the Colorado Railroad Museum in Gridley, Colorado. To better understand this project, we really have to kind of make the distinction between what a throttle is. Most likely you have some form of a handheld throttle, maybe through computer control, where you have direct control over how fast your locomotive is going. You move a dial and essentially it sends it to your command station, that sends a DCC command to your decoder, and your locomotive goes to the speed that you want it to go to. Granted, you may have a decoder that has acceleration and deceleration and maybe some braking functions, but at the end of the day, you are controlling how fast it's going because you are acting as a simulator. Now in this project, we don't have that direct control. The simulation is always going, regardless of what commands are going, even if it's sitting idle. As soon as we tell the controls that we want to start moving, that in turn goes into the calculations and it determines based off the physics how fast will the locomotive actually start moving. And subsequently then it would send a speed command to the decoder, making the locomotive on the track go to the speed that the simulations determine how fast it would be going. It's just like a real locomotive. If you're in the cab and you notch up, that's ultimately telling the prime mover diesel engine to start going to a higher RPM, which produces more electricity from the generator that feeds to the traction motor that starts the locomotive moving down the track. How fast it gets going is based off many different elements, including the locomotive mass and grade and how many cars it's got. And that also affects how fast it will be able to stop and so forth. In this case, the handheld throttle doesn't have control over that. It's only going to be saying what I would like to do, but the simulation ultimately makes the locomotive do what it is actually capable of doing. Even so, this throttle simulation would work with any locomotive equipped with a DCC decoder. We really want the decoder to be custom set up for this. One of the important elements is the speed table. It needs to be linear because again, the software is calculating how fast we're going. And we only want 128 steps. We don't want the decoder to start creating hysteresis in the simulation. We also want to make sure that anything that interferes with how fast it goes or stops, like acceleration or deceleration functions, we want those completely turned off. And since our simulation is controlling the sounds, all the sound effects are all what I call toggling based functions, where ultimately the simulation tells every sound effect when it starts and when it stops. And if it needs to keep on making that sound, it just keeps on making that sound until the simulation tells it to stop. This demonstration of my locomotive with this custom set decoder shows what I'm talking about. As I go and give it a command to go fast or slow, it just immediately jumps as fast as it will and stops as much. It's not prototypical, but you'll see once it's under the hands of the simulation, it's going to do something completely different. I use the ESU LockSound 5 decoder primarily because you can use your own custom sounds or use sounds from their website, and the decoder has the ability to be custom programmed by the user on how the sounds are actually created or used. And Ted Nager, a sound engineer, customized the sounds and created a custom decoder program specifically for this project. So let's go over the functionality of the handheld throttle. We need the reverser, so we go forwards or backwards, and neutral, and then the emulation of the throttle stand, where we can set the notching of the prime mover, the independent brake and push to vent function of the locomotive, and we need our auto brake if we're going to have cars, and so we have to have the ability for filling and running and lapping, and in case of emergency, the emergency position as well. So here's a basic diagram of the whole setup. We have the handheld throttle, where the only role of the Arduino is to consolidate all the information from all the knobs and switches and lights and send it down a USB port. There is no simulation going on in the throttle at all. Once it's in the PC, that's where all the magic occurs and the simulation software is actually running. The simulation then sends out another USB port to my Digitrack control station that ultimately then sends the appropriate speed commands and sound effect commands to the locomotive that's sitting on the track. And I kind of spent a lot of time on the computer and software functions here, but just some of the basics. The software I wrote using Microsoft's .NET architecture utilizes the latest technology from Microsoft and tapping into the most I could from a Windows PC. This is including the graphics, where all my graphics, as you will see, are very rich. They're GPU accelerated because they're heavily animated. The multi-processing functionality, because as you'll see, my software doesn't just do the simulation throttle thing, but it also runs my entire layout. And it ultimately has to be able to talk to my Digitrack command station through a local net connection. Even so it's not required to be displayed, I can optionally show this dash that I created to give me the feedback of what's going on with the locomotive. But I didn't want it to have that game look, so I actually spent quite a amount of time to make this operational gauges and switches and lights have that grungy but yet realistic look. And I'm showing it to you in this fashion right now because when we get into the software, since this YouTube video is only 1080p, this gives you more of an opportunity to actually see how detailed the graphics of the dash really are. So let's go over the basic functionality of my train layout software. This is my layout. Everything that's yellow is occupied. Red is where there's conflict. I can use the touchscreen to pan and zoom to enlarge an area. I can change my turnout selections, just telling it which path I want it to go to. I can double tap to go to the original size. I can control my turntable by just stating where I want to go, and I get a nice graphical feedback of its actual position as it's moving backwards and forwards.
Yeah, this is dispatch. Over.
Like my cab project, I wanted to have the radio dispatcher. It's not just used for the throttle, it's also used for my layout to provide a vocal feedback of any issues. In this case, I'm setting one of the turnouts to be in a position that would be a problem. And as soon as the locomotive approaches that area,
hey, you have a turnout conflict ahead?
You hear the radio, which then I have to manually go and toggle the turnout.
Dispatch to WP 913. You're now cleared to proceed. Over.
If I tell the dispatcher I want it to auto-fix when I approach it.
Hey, hold on. I'm going to fix this turnout conflict you have ahead. Dispatch to WP 913. You're now cleared to proceed. Signal at progressionary speed. Over.
It automatically found the conflict and set the turnout for me so I could proceed. So let's go over the basics of getting this throttle going. In this case, I'm going to use the radio so we can get some feedback if we do anything stupid running the locomotive. I go into the cab mode where I can also move it, zoom it, make it smaller, put it wherever I want it. And this doesn't even have to be shown while we're running. It can continue to run in the background. To add a Locomotive to the simulation, I go in and select the DCC address, and as soon as I activate it, the simulation light on the very bottom is going. So the simulation is now running, even so nothing is running on the track. I can also toggle what in a debug mode, where I can see all the details of what's going on behind the simulation. For adding cars and mass, I have this interface where I can add cars or remove them. Okay, so we're going to start running this locomotive here that's got the custom lock sound decoder in it. So I'm going to start, and you'll notice that the throttle here is flashing indicating the locomotive is actually starting, but hasn't been started yet. Also take notice of the locomotive panel, all the gauges and dials and so forth on the different animations that occur. I do have the sound in the decoder extra loud, just so it picks up on this video. So I have this set up so it's just the locomotive, so I'm just going to be using the independent brake. There's nothing to vent. Put the reverser into forward, and I'm going to start notching up, and we're going to get this nice smooth acceleration that's coming. It's not the throttle, it's not the decoder doing this, it's the simulation. And I'm going to go all the way down to notch 0, which essentially is making the locomotive now coasting. And I'm going to use the independent brake, and I'm going to just slowly stop it. Did a little bit harder, and that's why we had the brake squeal. I just vented out the independent brake. I'm going to go backwards. I'm going to try to do a softer stop. You can see how, even so I'm really notching it up, it's only accelerating what this locomotive and the way it's geared to really do. I'm going to try it one more time, going the opposite direction, and trying to do a better job stopping this thing. So that was a pretty good stop. So now we're going to do a simulation with the effects of load and coupler slack. I only put 2 actual cars on here, but I'm going to tell the simulation we have more than that. So I'm just going to add 2 cars to there. So now when we start moving, it's not going to move as fast as it did before. And if you watch actually carefully, the locomotive will move, pick up the slack, move, slowly pick up. And if I over notch it, we'll get some wheel slippage as well. You can hear that. If you listen carefully, you can hear the clap. The couplers all engaging. it's slowing down, speeding up. And now we have all the slack out. You can see I'm pulling current. Now we're getting wheel slippage and the prime mover's running away because wheels are slipping. I've regained my traction. And I'm back to coasting. In this case, I'm going to use the train brake to best effectively stop this thing. Now I'm refilling the brake pipe, you can hear it. And by the way, the simulation is based off having multiple full weight cars. They're not empty. In this case, I'm going to use emergency. To stop it. So now what I'm going to do is, with all these weighted cars on here, I'm going to bring the locomotive up to speed, and instead of using the train auto brake to stop it, I'm going to use just the locomotive brake, which is subsequently going to force all the cars to plow into the back of the locomotive and make it jerk forward. So I need to get the thing up to enough speed, and let's see what it does. So again, we got to take out the slack and everything. Once you've taken the slack out, it stays out unless you reverse direction. Some of you may have noticed the speed recorder bobbing below 10, and that's what the Braco speed recorder really did below 10. It oscillated. This is probably enough speed. So I'm going now. I'm in neutral, we're coasting, we got all this mass behind us, and I'm just going to hit the locomotive. And you can see, not only did the cars actually start piling into it, but the locomotive made a little jerk forward. It's as fast as I can make it do based off how fast the decoder allows you to make speed changes. They purposely make it so you can't really make any aggressive speed changes, where in this case the software would take advantage of it if it did. So now I'm going to do kind of an extreme thing. With the locomotive off, there's no brake pressure on the locomotive. The brake pipe is filled, but essentially this train has no brakes on it. It's just sitting there. And even so, we don't have the locomotive running, or the simulation is still running. And so I'm going to go and change the grade. See what's happening? We've got to run away. So that concludes my demo of my handheld throttle project. We'll see if we have any updates in the future on it. Thanks for watching.